I think we're about to have a second big revolution with regard to age-related diseases.
The field of longevity is really booming because we all are looking as to how can we live longer and better.
Every new technology brings possibilities, and then it's the question of ethics to decide whether those things should be done just because they can be done.
You know, one of the reasons that so many people survive the coronavirus is that we have a diverse population. Some of us are at risk, some of us not. If we all had exactly the same genes, we run the risk of all of us succumbing to some virus that comes around. Diversity is critical.
Clear as well that medicine and advances are going to encounter a fundamental barrier if they do not have access to the full consolidation of individuals' medical data, genetic data, life history, behavioral data. And that is the problem that I am trying to address, to create a knowledge base per individual in a self-owned way.
From the Zoomerplex in historic Liberty Village, the Zoomer with Libby Znaimer.
Welcome to the Zoomer. I'm Libby Znaimer. How far are we on the path to redesigning a life without illness and disease? Can the science and medicine of today intervene at the DNA level to give us the tools to fight off viruses like COVID-19? Will there be a point when we will no longer be susceptible to bugs? And where is the science of redesigning life headed? And what questions are being raised? Joining us today, Michael Fossil is president and founder of Telesite, a doctor, an author, and DNA specialist. Father Raymond D'Souza is a journalist and columnist, as well as the chaplain of Newman House Catholic Chaplaincy at Queen's University in Kingston. Igor and Olga Kabalchuk are with the University of Lethbridge. Olga's specialty is epigenetics, and Igor runs a lab at the university studying plant biotechnology. All four are alums of Moses Znaimer's Idea City Conference. Also joining us is Alan Brooke, a futurist and founder of the Humum State Foundation. He'll be appearing at our next Idea City Conference. Before we dive in, let's tee up the topic.
Viruses are tiny, ranging in size from about 20 to 400 nanometers in diameter. Billions can fit on the head of a pin. Viruses aren't considered alive. They require a host to begin to function. That's why they're so hard to kill. This is especially true of the deadly coronavirus. But as soon as it gets into a human airway, the virus hijacks our cells to create millions more versions of itself. As researchers race to develop drugs and vaccines for this disease, others are exploring whether gene editing technology can be used to fight pandemics. In the meantime, we shelter in place.
Is the idea of eliminating disease just an extension of the progress we've already made? And what about viruses like COVID-19? Michael?
I think we're always going to have disease. We're always going to have viruses. You know, it's sort of like the Red Queen. You always have to run fast to stay in one place. But I think we can make enormous progress. You know, if I look back over the past 200 years, we've already conquered a number of diseases. And I think we're about to do something quite revolutionary. But we're never going to conquer everything.
What will be revolutionary?
Well, as I look back and I ask, what have we really done in medicine that made a difference? I think the biggest difference has been a conceptual revolution. That is the idea of microbes. It allows us to conquer a number of diseases that we previously suffered from. And to my mind, that's the big thing, a conceptual revolution, rather than little technical advances like robot surgery or the latest statin or heart transplants. I think that when you look at something like microbial theory, it's allowed us to not only increase human life, but more importantly, increase the quality of human life and actually lower the cost of medical care. I think we're about to have a second big revolution with regard to age-related diseases, and likewise, actually lower the cost of medical care while improving life.
Alan, what's your take?
I agree with Michael. If we look at evolution, It's never going to end. Even if we take care of the ancient problems such as viruses and bacteria, there will probably be problems in the future with people synthesizing pathogens. This may be as a mistake in an outcome of providing cures, because every powerful tool also has the downsides. And it may be also by malicious actors, government or individuals.
Igor and Olga, what's your take?
Well, we come, or myself as well as Igor is also in this field, in the field of epigenetics. So epigenetics is referred to as above genetics or beyond genetics. And we take that as a science of hope. Well, we all know that right now, longevity industry and overall the field of longevity is really booming, because we all are looking as to how can we live longer and better. And to that effect, what we believe is that, yes, your genes, your DNA holds a lot of the keys to answering lots of questions. But epigenetics, which means the science of how your genes act, how your genes are regulated, holds a lot more keys. If we were to take examples of identical twins, it's not necessarily they have the same disease, even if they carry the gene pool. So our environment, our physical environment, biological environment, social environment has the influence. What we eat, what we do, what we think has the influence on how our genes act, and respectively how healthy we are or how sick we are and how long we live.
So Igor, again, is it realistic to want to eliminate disease? Is that what we're trying to do?
Right. Well, unfortunately, it's wishful thinking. We cannot eliminate diseases, especially caused by pathogens, right? So it's a part of the evolution as a process. However, we can mitigate the disease much better, as Olga said, and we can make the medicine personalized, right? So nowadays, there's so much data on the effect of specific condition or on molecular profile of a specific disease that we can run our artificial intelligence, machine learning, for example, deep neural networking, to identify those patterns and actually predict whether the individual has a predisposition of the disease, whether the individual develops the disease, or which drug simply to choose from is better suited to curb the symptoms.
Okay. When we come back, can your genes be turned on and off to fight disease? That's next.
It offers really a lot of opportunity to influence the levels of gene expression to actually control a variety of different diseases.
Welcome back. We're born with certain genetics. Some get expressed while others don't. The difference is influenced by environmental and behavioral patterns. And Olga, what exactly is gene expression, and why is it that we're seeing such a vast spectrum of the severity of COVID-19 symptoms?
Well, this is a really great question. To give you an example, what is gene expression? In each cell of our body, we have the same DNA. Liver, brain, muscle, they have the same DNA, but the cells look different. Liver cells are different from muscle cells. Why? Because different genes of those roughly 30,000 that we have are active at different levels. So, and that activity oftentimes in science terms we call gene expression. And it offers really a lot of opportunity to influence the levels of gene expression to actually control a variety of different diseases, be it diseases such as inflammatory disorders, chronic disease, or even diseases like COVID-19.
Let me ask you, so do you think that the reason behind such a huge divergence in the severity of COVID-19 symptoms, some people have no symptoms at all, some people have mild symptoms like a bit of a cold and it kills other people, could that be because of their genetic makeup?
I think so. I think it's different to some degree of their genetic makeup. We will still need to take a look as to specifically the gene-virus interactions into more details, but it also has to do with different levels of expression of a special protein of the receptor that brings that virus into our cells, as well as of different genes that are responsible for something we call a cytokine storm, a storm of our immune system's responses that occurs it actually affects the lung tissue. That's why people have acute respiratory distress syndrome. And in some cases it occurs and in some it doesn't. So in some people, their genes get so overactive that their body tries to fight the virus and as a consequence kind of damages the lung tissue. So that has to do with different gene expression and it can be influenced.
Michael, what's your view of this?
It's odd that you ask. I mean, maybe you know, I give a weekly global COVID call for people who are interested in sort of keeping up on the perspective. One of the most remarkable things we've noticed about COVID as compared to many other viruses or other diseases. I mean, COVID is the disease, coronavirus is the virus, but one of the things we've noted about COVID is the extreme fatality rates in older people. It just goes up exponentially with age. And that, again, turns out to be epigenetic. It has to do with cell senescence and changing gene expression in older people. As a lot of, I think, people know, certainly Olga does, you know, she said the genes when I was 9 and the genes now when I'm 69 are the same genes, but they're expressed slightly differently. And it's a pattern of gene expression that makes a very big difference in the fatality rate for example, COVID-19. So yeah, it's enormously important. The genetics play a role too. But roughly speaking, about 3% of my genes are involved with expressing proteins, and pretty much all the rest of them are involved in regulating that 3%. So epigenetics is critical to understanding diseases.
I want to get back to genetics because I'm wondering if there's a kind of parallel as with cancer treatment, because we have personalized medicine, precision medicine. That means that even if you have the same kind of cancer, it looks the same under the microscope, one treatment will work on one person and not on another because of their genetic makeup, and they're using that to target the treatment. Is that possible that the same thing is happening with a virus like COVID-19, Igor?
Well, absolutely, because if you look at how the virus or any pathogen gets into your system, it would depend, as Olga said, on the expression of the proteins that are on the surface. Those that have high expression of the protein and high affinity to the virus ligands will get infected more, right? Those people who have the ability to replicate virus without any obstruction, let's say, will get the virus spread faster, right? So then if we talk about any medicine we use, that medicine may have influence the disease very differently depending on what is the pathology of the disease in the cell. In addition, our ability to metabolize those drugs and the system of detoxification of any compound have a huge effect on our capacity to either keep the drug longer in the system or get rid of it very quickly. So all of this is very individualized, and the personalized approach makes it a very unique way of treating this disease more efficiently in one case than another.
Father D'Souza, do you have a view on this?
On the specific science of it, I'm a layman in that category, and I'm very interested to hear what our scientists have to say. Some of the questions that will arise if these types of therapies are successful are more broadly social and cultural questions. I mean, society is quite different when you have a life expectancy of 75 or 80 as it would be when it was 30 or 40 years ago in previous centuries. What does it mean to work? If you're going to live to 85, does it mean you have to work till you're 65? Do we want to live longer if the quality of that life is compromised, or will we just be bored? I mean, these are kinds of questions that are going to be profound, and philosophy and theology and sociology and all the rest of it, including politics, sometimes takes a while to catch up.
Okay, well, those are the questions we are going to tackle next, the ethics and advances behind genetic engineering. Don't go away.
But what if you could have an extra 30 years playing with the grandchildren, playing tennis, gardening, traveling, doing things you enjoy? Different matter. It's a quality of life, not a quantity of life.
Welcome back. Viruses are the smallest of all microbes. They are so small that 500 million rhinoviruses, which cause the common cold, could fit onto the head of a pin, which is why one sneeze or a cough can spread millions of these viral cells through respiratory droplets, making social distancing and self-isolation so important. But viruses are also critical to the future of treating diseases. Gene therapy uses genetically modified viruses to deliver genes that can cure diseases in human cells. So what are the promises of resetting disease and aging at the genetic level? Michael.
Enormous, and more now than ever before. And you're right, the gene therapy is really a huge advance for us. It's given us a tool we've never had before. The most common one now is called adeno-associated virus, which is a handy little tool to have. And I think it's already allowed us to do things like essentially cure some childhood diseases like spinal muscular atrophy. But I think you're going to see enormous advances over the next 5 years simply because we have that tool available.
Olga?
Yes, absolutely. With all the new tools and all the new knowledge that's becoming available, I think it's really, really important to tackle diseases that have a genetic component. But it is equally important, even more opportunities exist there in trying to influence the gene expression levels. And that is technologically easier, and that can be done. And actually, it is being done for numerous types of diseases, including now for COVID-19, using some very new and very promising approaches.
Such as?
Well, such as most recently, I should say, yesterday, we filed a patent on using new cannabis extracts and cannabis derivatives against some of the aspects of COVID disease, against bringing the virus into the cell, the receptor, the level of the receptor that brings them in, as well as against the molecules that are behind that very aggressive cytokine storm and essentially lung failure.
Alan? Does this have an impact on the work you're doing?
Yes, it certainly does. Clearly, I have no medical expertise, but it is clear as well that medicine and advances are going to encounter a fundamental barrier if they do not have access to the full consolidation of individuals' medical data, genetic data, life history, behavioral data. And that is the problem that I am trying to address, to create a knowledge base per individual in a self-owned way, because currently this information, at least in the US, is dispersed and owned by a multitude of entities. If a person changes the country of residence, you lose a lot of this. And without the totality of an individual's information, AI systems and other advances in genetic engineering not able to function optimally. And this is why it's necessary to create, on an individual basis, a massive self-owned database together with the applications in a safe way under an administration that is aligned, intrinsically aligned with the interest of the individual.
Father D'Souza, what are the ethical implications of this genetic engineering?
Well, it's a very exciting time because all of a sudden, or maybe not all of a sudden, but rapidly, we're able to treat diseases that we weren't able to treat before, especially perhaps degenerative ones that can be very burdensome. The question with any new technology is just because you can do something doesn't mean that you should do something. We know that with, say, just information technology, we have all kinds of ethical questions over ownership and privacy that we didn't have before. Specifically, when it comes to genetic therapies, the question, there are two kinds of questions, I suppose. One is this repairing something that's broken, or are we trying to enhance something that's not broken, but we would like it to be better in some way? I mean, this is the sort of the specter of breeding sort of a superhuman child or a superhuman group or something. That's one set of ethical questions. The other one is to do with justice, is that who has access to this information, who has access to those therapies. We've already seen it a little bit, for example, in when genetic testing can reveal a proclivity to a certain disease. Does your insurance company have a right to know that before they insure you or not? That's one. That's not a future question. That's a question already that governments in Canada have legislated on. So every new technology brings possibilities, and then it's the question of ethics to decide whether those things should be done just because they can be done.
Igor, how do you deal with those ethical questions as you look to new therapies?
Well, as you deal with any other ethical question, so you have to be fully transparent. So you have to keep public information flowing, right? So while you have to study it more, so nowadays there's, I would say, a limited number of such experiments done in humans. So mostly it's done in vitro, right? As soon as you follow the path of maximum knowledge gained and maximum information out there, people will be aware of this and the acceptance would be much better. And the government plays a crucial role in there as an acceptance of any other new technology.
Michael, again, how do you handle this?
To my mind, it's a question of compassion and problems that people have. It's, for example, I have no interest in extending human lifespan, but I have an interest in getting rid of disease, fear, pain, tragedy, the kind of things that make people's lives poor. Marcus Aurelius once pointed out 2,000 years ago that it's not a question of how long you live. It's, in some sense, we all live the same amount of time. It's sort of how well you live. And as a physician, that's what matters to me. It's a matter of compassion and improving lives. Example, about 5 years ago, the Pew Memorial Trust did a survey in Canada. And one of the questions they asked is, would you like to live an additional 30 years? And most people, surprisingly perhaps, said no, because they thought that meant an extra 30 years in a nursing home, which is not the point. None of us want that. But what if you could have an extra 30 years playing with the grandchildren, playing tennis, gardening, traveling, doing things you enjoy? Different matter. It's a quality of life, not a quantity of life. So I think the ethics strikes right to the heart of this, and he's right.
Okay, thank you. When we come back, how cannabis may be on the front lines of treating COVID. Don't go away.
So here you are trying to walk the fine line of eliminating the virus and essentially kind of being careful around the host of our own processes. And different, also it's very important that different viruses affect different tissues.
Welcome back. More than 3 months into the novel coronavirus pandemic, and it's still unclear which drugs could combat the viral disease and which won't, and whether some drugs will work for some people and others will need other drugs. That takes us back into the area of personalized medicine. And again, Michael, do you see that as an approach for dealing with this viral outbreak?
It's funny you mentioned that because there's been some changes in the government regulation I've seen in different countries around the world, much more openness to moving some of those trials out into the public. For example, the FDA is now talking about the possibility of switching from looking at safe and effective to looking at safe and then letting the market determine what's effective. Those sort of broad spread trials will give us a chance to see if you respond differently than I would, who responds differently than Olga does. So yes, I think there's a chance that we're changing the way we look at medicine solely as a result of coronavirus.
Okay, I mean, I come at this from a very personal example. I have BRCA2, that's the gene, the mutation in the gene that predisposes me to cancer. I've had cancer twice. The second one was very serious. It was pancreatic cancer, a third stage. An advanced third stage, and because of my mutation, they gave me a drug that took on my mutation, and here I am. So I'm just wondering if that's an approach as we, try to deal with this latest problem. Igor.
Well, absolutely. So in your case, what you mentioned, basically, if you use a personalized approach, you can design a therapy that would activate or inactivate a gene in specific tissues. So cancer is a good example, but any viral disease would be similar because viruses are very tissue specific. So if you know what gene is overexpressed or under expressed, you can design genetic editing tools like CRISPR-Cas that either would permanently fix this mutation, so to become normal nucleotide, or actually to remove or add a regulation, for example, DNA methylation that would either suppress this gene or make it active, right? So, and again, this has to be done individually because there is a great individual range for any specific disease.
Olga, why is it so much harder to treat viruses with drugs than bacteria?
Well, first off, because viruses are very interesting creatures. Actually, viruses are not considered to be alive. So viruses are not the lowest form of life. Bacteria are. Viruses are only alive when they get into our cells. So in order for them to live, they need to get into the host cell. This is only where they can replicate and make more of themselves. So essentially the features of life is the capacity to reproduce, and they only reproduce when they get into us. So there is this interplay between the virus and the host that is, so in this case, you have two sides of the coin. You have a virus and you have a host. And whereas if you're treating bacterial diseases, you're actually trying to kill the bacterium, and oftentimes you pretty much spare the host. So here you are trying to walk the fine line of eliminating the virus and essentially kind of being careful around the host of our own processes. And also it's very important that different viruses affect different tissues. So there is tissue specificity, like rhinovirus affects our upper respiratory tract, as does coronavirus, which also affects our intestinal tract, but it doesn't affect other tissues. So we have to factor all those factors in when we try to influence the outcomes.
What about this whole business of trying old drugs for new uses? And we're seeing that with COVID-19. There's a lot of talk about chloroquine, and I know this happens a lot in cancer therapy, where a drug that's approved for one type of cancer is being used for another, or sometimes we've seen diabetes and heart drugs being used for another. So, Michael, what is the future possibility of that for eliminating diseases?
I don't know about eliminating, but it certainly would give us a lot more flexibility. We have a tendency to think of particular drugs in categories. Example, we think of penicillin as an antibiotic, but actually if I put it on almost any mammal brain, it causes seizures, and the mechanisms have no relationship to the mechanism that's used to kill a bacteria with penicillin. Anytime we call any drug an antifungal agent, an anti-malarial agent, an antibiotic agent, an anti-cancer agent, we sort of lock ourselves into this narrow little box. Almost any chemical we're using tends to have multiple effects throughout our body. And the question is, are some of those effects also useful? So yes, if you're looking at something like chloroquine that we think of as an anti-malarial drug, it might also be effective against coronavirus. That's honestly a good question. We have to find that out. It's still sort of an open question today, but it's intriguing.
Well, yeah, but that's just one example, but as a bigger area.
Yes, although I think that's not the only thing we should be looking at. Let me give you an example of this. Say we went back 500 years and we're looking at something like smallpox. And all we knew was about thousands of different herbs and roots and barks. And to be honest with you, the typical herbalist 500 years ago knew more than I will ever know about that. And they were probably very effective. But they had no concept of microbial disease. And I don't care how effective they were in choosing different herbs, as we might with choosing different drugs, their major problem was a conceptual one. They could not conceive that diseases were caused by microbes. I think we do the same thing sometimes with certain diseases, particularly age-related diseases these days. So while I think you're right about things like coronavirus, sometimes the advances we need to make are not simply in looking at different drugs, but in looking at the way we look at diseases.
Okay. When we come back, science versus religion. What are the ethics of redesigning life? That's next.
As we get more skilled in genetic interventions and genetic knowledge, we have the capacity to make great advances. But that's the question, is are we repairing something that's gone wrong, or are we seeking to enhance?
Welcome back. Genetics' biggest promise is unlocking the genetic basis of disease, and genomic sequencing could help us understand COVID-19 and its spread by allowing us to understand how it's spreading and whether different strains are emerging. But when it comes to genetic engineering and genetic editing, are we playing God? Father Raymond, what is the Catholic Church's position on DNA manipulations?
Well, I'd go back earlier to say that if it's aimed at correcting a disease, then generally speaking, you'd find a favorable ethical judgment. If it's aimed at enhancing something, so you're intervening to make someone, say, apparently more intelligent or more athletic, then you run into questions of justice about who has access to that and whether, in fact, the implication is that those who are not enhanced are somehow lesser. The broad category under which all genetic work falls is, or against the background, I should say, is the specter of eugenics, which has a very long history. And so knowledge of genetics can lead to enhancements in healthcare. But we also know that the history of eugenics means that often those who are diagnosed as being less than, for whatever reason, can be denied treatment, or, as is the case today, for example, the main sort of ethical question would be on the diagnosis in utero of things like Down syndrome, which in Canada anyway leads to the vast majority of children never being born who are diagnosed with that. So as we get more skilled in genetic interventions and genetic knowledge, we have the capacity to do make great advances. But that's the question, is are we repairing something that's gone wrong, or are we seeking to enhance? And then those who are not enhanced or found to be lacking in some way, are they entitled to the norms of justice? Those are the broad questions that would apply and have applied really for as long as the science of genetics has been around, which of course is at least 200 years.
Olga, what's your view? Remember that rogue Chinese doctor who genetically engineered an embryo, and I believe that he engineered it to be resistant to HIV. What is your takeaway from that whole episode?
Well, this was quite, I would say this was to some degree quite troubling when it all erupted. And I think there are still lots of questions that have to be answered about what exactly happened, what has it happened. But I fully agree here that one thing we really do not want to do is we do not want to live in the Gattaca world. If you remember that infamous movie Gattaca, where everybody's DNA was sequenced, and if there's something teeny bit wrong with you, you essentially kind of eliminated. So we don't want that. We do have the possibility to correct something, but again, as soon all of those ethical issues we have to be really very, very privy about those, and we really need to be focused on them, because as scientists, when we understand that there is lots and lots and lots more technology becoming available, we have that propensity to start using it, and we always have to look back as to, yes, at which point do we start playing God? And when they announced that they probably did edit that embryo, I actually was very, very concerned, because the other thing we don't know is what's going to happen to that human being. Is that child even going to be healthy? If we don't know. A lot has to be learned, and we as scientists do have responsibility to actually really take care of it properly.
Okay. Let me take an example, and again, I'm going back to me. So I have this genetic mutation, and at one point I was talking to one of my oncologists, who happens to be, I was quite surprised, an Orthodox Jew, and she told me that now when they're counseling people who have the mutation and they want to have children, they would do in vitro, And they would check the embryos and get rid of the ones that had the mutation, because there's a 50% chance. And I'm kind of thinking, I would have ended up on the cutting room floor. Father DeSouza, I'm pretty sure that your religion doesn't approve of that kind of thing, but in general.
Well, no, but that's actually quite a universally shared position, even amongst non-religious people, amongst the history of philosophy. The idea that the weaker should be eliminated, that's what I said, the specter of eugenics is before us. Now, if they could come up with a therapy so they could intervene at some point and say, correct this predisposition, that would be an advance. But if the technology is used to say these people will not be born, and that is, as you mentioned in the counseling that you got or that you heard, is already being done, that's where the specter of eugenics comes in. And it has a very dark history, not just in totalitarian countries, but even in progressive countries. And that's the specter we have to be very careful about, is that the weaker, however defined, are not excluded, or even, to use a more chilling term, eliminated.
Michael, we are in the age of CRISPR. So what is to stop scientists from using that technology with or without applying ethics?
Well, actually, I'd like to expand on one of the points that Father made, because he's right. And it bears on the question you're asking. It's pretty easy for us to define a disease if it causes pain, discomfort, that kind of thing. But the you, as in eugenics, making something better, that's not so easy. It's clear what's bad. It's not often clear that we know what's better than what we have. I get a little nervous when people either try to, for example, say we could improve your body by making it taller or more muscular. Is that really an improvement? I don't know. If you've got a paralysis, it's pretty clear we need to fix it. But defining what somehow is better is not clear to me. And it also bears on the issue of undercutting diversity. You know, one of the reasons that so many people survive the coronavirus is that we have a diverse population. Some of us are at risk, some of us not. If we all had exactly the same genes, we run the risk of all of us succumbing to some virus that comes around. Diversity is critical. And I think that's part of why I get nervous about eugenics. It's not clear that we know what good genetics are. It's pretty clear we know that bad genetics can cause pain or discomfort, and that should be done away with. But defining what's better, no, that makes me nervous.
Okay, when we come back, final thoughts from our panelists.
I think we're about to do something even more dramatic in the history of medicine in the next 10 years, and that is finally begin to prevent and cure age-related diseases.
Welcome back to theZoomer. It's now time for final thoughts from our panelists, starting to my left, which is Michael.
As I look back again in the history of medicine, the last 200 years, we've made an enormous advance with regard to microbial theory. Saved a lot of lives, got rid of a lot of pain and discomfort. I think we're about to do something even more dramatic in the history of medicine in the next 10 years, and that is finally begin to prevent and cure age-related diseases.
Alan?
I definitely agree with Michael, and I think the main point here in discussing ethics and the future is to take as the basic premise that the individual should make the decisions at the end of the day. There should be individual freedom, of course, as long as it doesn't overtly impact others. And this is why we need to revert the control and the ownership of genetic data and medical data and decisions to the individual.
Father DeSouza.
It's an exciting time, what the possibilities that are before us. But whenever we have a more powerful tool, the responsibility for using it increases, and the ethical reflection required. And we see that, for example, in the 20th century with weaponry. We got bigger and better and more devastating weapons. We need to think more critically about the ethics of using them. Medicine is a powerful remedy, but can occasionally be used even as a weapon. And we got to be careful about that we take the good and leave the bad. That's not easy to do. And we have to make sure that our ethical reflection, our philosophical and theological reflection keeps up with our scientific advances.
Olga?
I think to that effect, the science of epigenetics, we view it as a science of hope, because even though genetic engineering can change genes, even though it could be a bit ethically controversial, trying to look at how you can make your genes function better through environmental enrichments, through what we eat, through what we do, that offers hope. And to that effect, I'd say there is a lot of effort now going on to stop COVID-19, and all of us as scientists, as physicians, and are involved in looking for new disease cures. And again, we are looking at it from the standpoint of epigenetics, which is a science of hope. And we really are keeping our fingers crossed that looking for partners now to start new trials, to look for the new ways to influence expression of the genes that bring the virus in and that actually damage our lungs.
Igor?
Yeah, I think we'll live through all of this. Our cumulative knowledge is vast, and the future is basically personalized medicine. So imagine everyone at home will have a little station, like a small fridge of a kind, where you deposit your bottle swab every morning, and by the time you finish your breakfast, not only are you fully diagnosed, but you have your personal medicine synthesized.
Okay. Thank you for being with us. One thing is clear, science will continue to help us live healthier and longer. We'll see you soon. It's time to zoom out.